We're honored to have with us the creative and technical team behind the recent Secret Sky production. It was an all-day concert that debuted in WebXR with songwriter and performer Porter Robinson spearheading the vision and the curation of this Keystone virtual event. I'm looking forward to hearing insights from the team behind this event and learning about everything that was involved in making this vision come to fruition. So welcome team Active Theory.
Hey, thanks for having us. Over the course of the year, we kind of developed the Dreamwave platform, and then kind of when the second version of Secret Sky hit, we had the ability to create these avatars that could run around multiple different environments. We could get the live stream directly into the feed. So you're kind of bringing together all these different audiences for the first time, and it's just really interesting to create these sort of digital destinations where you don't really know what's going to happen, and we're kind of just we're a part of this experience. We're a part of this this new form of connection between devices.
The reception to it and the press inquiries and everything was just wow, this is a thing. There's a real kind of desire here. There's a real opportunity to create kind of something that meets in the middle between social media and gaming and entertainment. It's a little bit more of an art than a science. It is knowing what types of shaders to use. We have processes built in that allow us to write shaders that before the shader compiles, it checks, is this running on an old piece of hardware, and maybe it strips out, a complicated noise algorithm in a shader, things like that. So a lot of that stuff is built in.
We're always pushing our work as far as we can in terms of performance. So we ended up building our own WebGL library. So I think the more that we can kind of push it and squeeze out of the devices, the more we can start to kind of rival some more games basically.
One of the members of our team kind of was just playing around on the weekend and came up with the ability to use Houdini to render lots and lots of avatars with arms and legs, and they can all run independently of each other. So we kind of, that's one example of how over the last year, the platform just got better and better. On our end, when it comes to making a Dreamwave immersive event like this, it's very much like using Unity in the browser. I mean, I always say that it's the easiest thing to understand. It's not actually Unity. It's we built the entire thing from scratch. It is JavaScript the whole way down, custom WebGL renderer that lets us do lots of really crazy stuff with rendering so many avatars and things like that, but also a full featured level editor. So Mo and Kimbo are able to literally make stuff in C4D and Houdini and then just bring it straight into the browser.
It really does feel like an extension of whatever 3D software you're using. So whenever I'm modeling an object or sculpting it in Cinema 4D or other software like ZBrush and such, just a few clicks you can export it and actually see it live within the context of the scene.
Some small wins that ended up making the shaders a lot more optimized for the whole experience were things like repeat textures that don't require as much storage but can pack more information, and kind of blending different textures together so that they create more detail at a close-up distance, but as well from afar away we can strip down things that we don't need. Like if you're on a mobile device, maybe making sure that a certain texture doesn't load.
One of the things that we also used, which is actually really interesting, was we used the video texture to power the lighting systems in the environment. If you remember the experience, it was kind of audio reactive to the visuals. What we did there was plugged in the video texture hundreds of times across all the environment, and because it had already sampled the texture, it was actually pretty performant. So it allowed us to create these really dynamic lighting systems. So if you went into the cube world, or if you saw the experience at night and had this kind of really light up stage, all of those were just powered by the video. That was a really cool benefit from us, and I did not expect it to be performant. I assumed if I sampled that video texture hundreds of times, that would have a performance implication. It probably did, but not as much as I had initially thought. So that was a really cool aspect.
To boil it down, it's a node server that we wrote. You're broadcasting your position to that server at 30 frames per second. That server isn't even processing any of that data. It's not parsing the JSON. It's not doing anything. It's just receiving a chunk of JSON data about your position and orientation. And if you're in VR, your hand position and orientation. And it kind of is just using proper multi-threading with the latest version of Node using shared memory. And what it does is it kind of just, you have a whole big server, lots of different cores, and each core has lots of different users' connections on it. And it's kind of just writing all that data into a big blob of data that represents all the users in the room at a given time. we rendered about 150 avatars, and each of those avatars is rendered with a single draw call. And we do little tricks, like we do the frustum culling and see like which ones are in your vision. And if it's not in your vision, it'll still not do any of the work in the vertex shader to apply the skinning animations. One of our artists figured out how to use Houdini to render, basically bake a skinned mesh animation. So in this case, a running cycle, bake that into a basically JSON data, right? It turns into a data texture. And so then what we're able to do is it's not just one skinned model, it can be many skinned models that can apply different frames of that animation, depending on where they are in the run cycle, at different times uniquely in the shader. So all the avatars, and there were 150 in Secret Sky, and I think we learned that we actually could have done more. We just kind of kept it a little bit safe, but we probably could have gotten up to 200 or so. On top of that, there's a lot of tricky interpolation that we do to make it look like, you know, basically hide the latency. So the avatar legs running is a product of the velocity of an avatar that's moving through space. So that's why you don't get this like jumpy look. It's very much interpolated so that way the velocity kind of is smooth, and because the velocity is smooth and the legs are attached to that velocity, you very much see it like the person is actually running. You don't see them kind of skipping and jumping through space. What we've kind of always hoped to do over the years, and what we hope to especially now to really accelerate with Dreamwave, is kind of show the browser vendors that, hey, this is a thing people want on the web, and that they should prioritize performance for that. And a lot has happened over the last few years that have really made that better, but I think like, you know, more so reliability and, you know, just steady frame rates. So yeah, we're all about the WebXR API and are kind of keeping up to date. We keep in touch with the developers at Oculus kind of about what the kind of where it's going, with what their current implementation of it is in the Oculus browser. And we, yeah, like do just basically are adding features to it as they come out.